Now we're going to consider another reason for there to be gains from international trade. And that is the situation or the case where markets can be bigger, can be expanded, as countries can do business in more than one country, more than one area. It's called the case of expanding markets. This particular idea focuses more on trade within the same industry. That is, two different kinds of cars, several different kinds of beer, intra-industry trade. And that is in contrast to the comparative advantage model, which focuses on inter-industry trade, trade with different industries. And that could be pharmaceuticals versus electronic goods. It could be lumber versus oranges. Those are different industries. Inter-industry trade is what comparative advantages focuses on. The other idea to keep in mind when you think about the theory of expanded markets, it's going to combine two features of production that were very much integral and part of the microeconomic theories of economics. One is economies of scale, which means that average total cost declines over the relevant range of production. So to repeat, declining ATC, average total cost, over the relevant range of production for the firms in the industry. And second is product differentiation, which means there could be two different or three different or many different kinds of beers, different kinds of toothpastes, and indeed different kinds of cars. And as you may recall, that leads to a situation sometimes called monopolistic competition, where firms have a little monopoly power within their own particular differentiated product, but there's still competition because the products are similar in many respects, two different kinds of beers, two different kinds of cars. So as we see, this is the theory that we're going to use to explain the gains from trade in the case of expanded markets. The model itself will involve several relationships, two to be specific, plus the interaction with these two relationships. The first relationship is between the number of firms in the market, in the beer market or in the automobile market, the total size of that market. Does it include the United States or the United States and Europe, or does it include the whole world, the size of the market? And the other thing that comes in this relationship is how much it costs to produce a unit. That's the average total cost. So that's the first relationship, how these things combine. The second relationship is one between the number of firms in the industry and the price of goods in the industry. So the number of firms producing beer and the average price of beer in the industry, for example. And then the third idea connects these two, and we'll see how they fit together in a nice, simple way that enables us to illustrate the gains from trade in this case. So let's get started with the first relationship. This is a curve which shows average total costs of production for a particular good. The difference between the left and the right is the size of the market. The market's going to be smaller on the left, and it's going to be larger on the right, as you can see. The green line is the declining average total cost curve. As you move out the horizontal axis, the quantity is larger, and you come down the vertical axis, the costs of production go down. So the more that's produced, the lower the cost of production. That's declining average total costs. And the same thing is true on the right, exact same green line drawn on the right, except we're going to have a larger market on the right. So first look on the left. This illustrates that if there's one firm producing, the cost per unit are the lowest. There's actually $10 per unit is average total cost for the case where there's one firm producing. In the case where there's two firms producing, that's the yellow line, they're basically splitting the market up. Now, since each is producing a smaller amount, the average total cost will be higher. It's 20 in this example. If there's three, it's 25. And if there's four firms splitting up the market, the average total costs are the highest in this diagram, or $30 per unit. So you can see that the average total cost is lower the fewer firms that are in the industry. And that's that relationship between the number of firms and average total cost that we're looking for. They're summarized in the table with color codes that correspond to the examples in the graph. The one on the right, that is the larger market, the story is the same, except now it's possible to sell a larger amount for whether it's one firm or two firms or whatever. That larger amount is illustrated by the fact that the quantity sold is further over on the right. The purple 101 is now a larger market. So this single firm in the market, if it's able to produce and sell that much, the larger market might be larger because of trade. It might be not just the United States, but it might be the United States along with Mexico and Canada, a larger market. So if the firms are able to produce for that larger market, the cost per unit will be lower. It'll be 5 in this example, the purple line, compared to 10 in the smaller market. And the same story is when there's a smaller number of firms. So if there's 2 firms in the market splitting, as in yellow, you see the average total cost 15, and so on, up to the highest average total cost for the larger market, which is $25 per unit. And so you can see not only is average total cost declining as fewer firms are in the market, it's also declining as the market gets larger for the same number of firms. And that's illustrated and summarized in the box over on the right, where you can see with the color coding, purple, yellow, green, and blue, that cost per unit or average total costs are uniformly lower in the larger market. So now we can summarize this information, which again is based on declining average total cost, sometimes they're called economies of scale, and looking at the number of firms and the size of the market. We can summarize this with a little curve. Just taking the data we found in those little boxes based on the graphs and plotting them. So here on the horizontal axis, we have the number of firms in the market. Example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And on the vertical axis, we have the dollars, in this case, representing the cost per unit or average total cost of production. Then all we've done is just plotted the points, again, keeping with the color code. So you can see with one firm in the market, we have 2 purple points, depending on the size of the market. The upper line, the upper points are where cost per unit is higher. That's because the total market is smaller. That may be because it's just the United States, not the United States, Canada, and Mexico, the larger market. If now Canada and Mexico join and we have a North American free trade area, which is where it's easy to sell goods within any of these areas, average total costs will shift down uniformly, regardless of how many firms there are in the market. That downward shift is just a summary of the derivation we got by looking at the average total cost curve itself. Nothing new in this diagram compared to the previous diagram. It's just a way to put the information together. You got movement along one curve as we increase the number or decrease the number of firms in the market, and we have a shift of the curve down as the market gets larger, or if you had restrictions on trade, up as the market got smaller. That's the first relationship. The second relationship has to do with the number of firms in the industry and the price. And this is based on the product differentiation argument completely. Recall, when there's differentiated goods, firms face a downward sloping demand curve for their product. There's some degree of substitution possible from one kind of running shoe to another. So if one running shoe manufacturer charges a lot, it will lose some customers as they go to the other running shoe manufacturer. So the downward sloping demand curve is the result. But what's also interesting is that when there are more firms coming into this industry, the demand curve will shift as there's competition becomes increased with more firms, more competition. It's still monopolistic competition. It's still a downward sloping curve, but the curve indeed will get so it's flatter and the price will fall as more firms enter the industry. And you can illustrate this in just a simple diagram with average total cost. So let's do that. Let's just have a standard kind of diagram where we have the quantity produced, and this could be the quantity of a typical firm in the industry, running shoes or beer or automobiles, whatever it happens to be, quantity produced by the typical firm. And on the horizontal axis, the vertical axis, we'll just have dollars. It could be the price or average total costs. And so we just make it really simple. Suppose there's a demand curve like that, and we're looking at average total cost declining in this case. So we could draw an average total cost like that. And it's still declining in my picture, so let's call that average total cost. It's declining through most of the range of production. And I've drawn it so that they're tangent at that point. That's the case where there'll be no economic profits, the average total cost will equal to the price, because as you know, the price will be on that demand curve, as we've argued before. We don't need to draw in the marginal revenue or the marginal cost curve to illustrate this, but they're simply behind the scenes. Now, with more competition, the demand curve will tend to shift. And it will shift reflecting the fact there's more competition in the industry. And so you could think of it shifting like this into a flatter curve. And as I've drawn it, this flatter curve has a tangency of the average total cost curve at that point. And since the price is represented at those points of tangency, we've seen that the price has fallen as that curve has shifted and flattened. More firms coming into the industry, that's more competition, a flattening of the curve. And so the price has gone down. And what's also interesting here is that you have the quantity rising a little bit. And more importantly, behind the scenes is that curve is flattened because more firms have come into the industry, each firm producing a slightly different product. And so you've got more product differentiation of this. You might have a beer made in Germany and a beer made in the United States, not exactly the same, but there'd be some product differentiation coming in as more firms entered the industry, as there became competition between Germany, United States, Mexico, Canada, all of whom produce different kinds of beers, and that's what this is illustrating. So given this argument, you see there's this relationship between the number of firms in the industry and the price. And indeed, we can summarize this with another curve, and there it is. More firms lead to a lower price. We've shown that in the diagram. Now we're just summarizing it in this new diagram. Number of firms on the horizontal axis, so that represents more competition going over to the right. And the price represented in dollars over on the vertical axis. And all we've just done is we just sketched in the fact that the price will tend to go down as more firms come into the market. Now, finally, we'll combine this second relationship with the first, and we get a little bit of a theory of what's going on. So we first have our curve that represents the fact that costs per unit will go up the more firms there are in the market. That's due to the decline in average total cost curve. So just to say what's in the box, cost per unit at each firm will increase as more firms enter the market of a fixed size. So that's a market for a particular size. This could be just the United States, for example. And we have our curve representing the price in the market, and that's falling as more firms are coming into the market. So in this particular case, we have maybe 4 firms is what the intersection is, and we have a price per product of $30 in this particular case. So this could be where it is if there were no trade, it was just the United States, and wasn't trading with Mexico or Canada or anybody else, whatever the example happens to be. Now you could consider the case after deriving this equilibrium between the number of firms and the price. Its equilibrium price is 30 again. Number of firms in the industry is 4. That's our prediction of this model. And now what we want to do is use the model as we've advertised to compute the gains from trade if the market gets bigger. As the market gets bigger, that cost per unit line will shift down. So we'll get a new equilibrium. So let's see how that works. There's the picture where we're starting. We'll call this cost per unit with a smaller market because we want to see what happens when the market gets bigger. So this could just be the United States, and now we're going to add in Canada and Mexico and have a North American market. That shifts this curve down, as we know. Cost per unit for each number of firms comes down. Cost per unit declines with the larger market for any level of firms, whether it's 4, 5, or 6. And now what we're going to get, since the relationship between the price and the number of firms hasn't changed, we're going to get a new prediction, a new equilibrium. And if you look, you can see that we've got a lower price. That's a measure of the gain from trade. We've got a price reduction from $30 to $20 per unit. That's you've come down. The number of firms in the industry has increased. That's increased the competition and tended to lower the prices. We've also had the fact that the market is larger. That's lowered average total cost for a given number of firms in the industry. But we're also predicting that the number of firms will increase, in this case from 4 to 6 in this particular example. And the fact that this is a product differentiation case, that increase in number of firms is an additional gain from trade because there's now more variety of projects, now more things that people can, who have particular tastes, so one kind of beer versus another, one kind of car versus another. They can take advantage of the fact there's more differentiation of the products, more products effectively being produced. So then to summarize, the model of expanded markets shows you yet another way that there's a gain from trade, gain from international trade. In this case, it's trade within an industry, within the beer industry, within the car industry, whatever it happens to be, unlike comparative advantage, which is trade with two or more different industries, whether it's fruit or vegetables or lumber. Here, this trade within industry, intra-industry trade, we're finding that we're getting lower prices as a result of the expanded market, so consumers are benefiting from that. They're getting lower prices because average total cost has declined. And moreover, they're getting more variety of products as the number of firms producing different products has increased. So it's yet another reason to think about the benefits and the gains from international trade. Added to the other reasons we've already considered, wraps up to a pretty impressive set of reasons to be in favor of trade and expanded markets. Thank you.